Now we have to talk about the party questions from the paper Electricity. First question is state Coulomb's law of electrostatics. Consider two charges Q1 and Q2 and are separated by a distance r. Then the force existing between them is directly proportional to the product of the charges and inversely proportional to the square of the perpendicular distance between them. Then to remove the proportionality sign, we have introduced a constant. It is F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 by r square. If these two charges are having same signs, then the repulsive force is dominating. Then if these two charges are having different signs, attractive force is dominating. One is plus and another one is minus, attraction is possible. Both are plus and both are minus, repulsion is predominant. If a distance r separates two point charges, the force between them is directly proportional to the product of their charges. F is proportional to Q1, Q2 and inversely proportional to the square of the separation distance. F is inversely proportional to r square. Then F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 by r square. Then the second question is define electric field. An electric field is a region around a point charge up to which its influence is realized. Here a point charge is taken for our consideration. The region around a point charge up to which its influence is realized. This is electric field. Now bring a test charge Q0 towards this point charge, then interaction force between them is Q naught divided by 4 pi epsilon naught r square into r cap in terms of vector. Then the electric field E equal to this force divided by Q naught. So without Q naught you have to write the value of electric field. The electric field at a point P positioned at a distance r from the point charge Q. From this point charge Q, the test charge is at a distance r. The electric field at a point P positioned at a distance r from the point charge Q is the force experienced by a positive unit charge Q0, that is the test charge, placed at that point P and is given by E equal to F divided by Q naught, that is equal to 1 by 4 pi epsilon naught Q divided by r square into r cap. And r cap is a unit vector pointing from Q to the point P. This is electric field. The third question is define electrostatic potential. You know that electric field is gradient of negative potential. So from this V equal to minus of E dot dr integral limit varying from infinity to r. Say work done in bring a unit positive charge from infinite distance to a particular point against the opposing force or electric field is called potential at that point. So that we may write V equal to minus integral limit varying from infinity to r E dot dr. The electrostatic potential at point P is the work done in moving a unit positive charge from infinite distance to that point P against the electric field. Then give the statement of Gauss law. The total electric flux linked with the closed network is 1 by epsilon naught times the charge enclosed by it. Mathematically we can write E dot ds integral, it is a closed network, that is equal to 1 by epsilon naught times the charge enclosed by it. What do you mean by capacitance of a capacitor? The ability of a capacitor to store electric charges is called its capacitance. The capacitance C is given by the formula Q divided by V. Next question is define farad. The SI unit of capacitance is coulomb per volt and is written as farad. What principle is involved in a capacitor? Consider a plate containing electric charges. This is a plate which contains electric charges. Bring another one electric plate closer to the first. See that we are bringing another one plate closer to the first one. Negative charges are induced inside the second plate and an equal number of positive charges developed on the outer side of the second plate. A plate with the positive charges are taken and bring another one plate closer to that one. So the negative charges are induced inside the second plate and positive charges are developed outside the second plate. Now the negative charges developed inside the second plate reduces the potential of the first plate. At the same time, the positive charges may increase the potential of the first plate. Suppose the second plate is grounded, these positive charges are removed from the second plate. Therefore, the potential of the first plate is highly reduced. As a result of it, the capacitance of the first plate is enhanced because C equal to Q divided by V. If V is lowered, then the capacitance is increased. So this is the principle of capacitor. State Ampere's circuital law. Ampere's circuital law states the relationship between the current I and the magnetic field B. The Ampere's law states that the integral of magnetic field density B along an imaginary closed path is equal to the product of current enclosed by the path and permeability of the medium. That is, integral B dot dl is equal to mu naught into I. This is closed integral. The ninth question is, what is a solenoid? A solenoid is a wire wound closely in the form of a helix. The wire is coated with an insulating material so that although the adjacent turns physically touch each other but are electrically insulated. State Kirchhoff's law of electricity. The first compartment is junction law. The sum of all the currents directed towards a point in a circuit equals the sum of all the currents directed away from the point. See this circuit, I1 and I2 are the currents coming towards the point O, but I3 and I4 are going away from the point O. Therefore, I1 plus I2, that is equal to I3 plus I4. This is called junction law. Then second one is the loop law. The algebraic sum of all the potential differences along a closed network is 0. Consider this closed network A, B, C, D, E, A. If you start our journey from clockwise, potential drop is taken as positive and the potential rise is taken as negative. Say A to B, VA minus VB is equal to I1 R1. This is potential drop, so we are taking the positive sign. Then VB minus VC, that is equal to I2 R2. Here is also potential drops, so we are giving positive sign. Then VC minus VD, their potential rise, so that minus E1. then VD minus VE, once again potential drop, so plus I3 R3. Then VE minus EF, see here VE minus VF, this point is F. If you take this region VE minus VF, here we are giving minus I4 R4 because the direction of the current is opposite. We are taking our account in the clockwise direction. Then VF minus VA, that is equal to E2. Here is also reverse biased potential is there, so that positive sign we have given. If you sum up all those things, you may get 0. So the algebraic sum of all the potential differences along a closed network is